Good morning guys and welcome to Mind Your Math. Today we are going to do the second chapter of grade 10, which is polynomials. Now you have already been introduced to polynomials in grade 9. You have learned about the definition of a polynomial, what constitutes a polynomial, so what doesn't constitute a polynomial, and the idea of factors and roots of a polynomial, etc. Now before we proceed with the newer concept that I have to introduce in this particular lesson, we will go through the basics, or we will just go through the basic concept we have already been introduced to. And if you have got any doubts regarding the contents of this video, you know where to mail me. My mail ID is given below in the description box. Now let us start with the class. Okay, so now let us start with the definition of a polynomial, or what are the expressions that come under the definition of a polynomial. Then in that case, you should also be aware about the expressions that do not come under the definition of a polynomial. Before we move on to polynomials, we know that the idea of polynomials came from the idea of algebraic expressions. Algebraic expressions is a concept you have studied in grade 8. Now algebraic expressions has come from the idea of variables, and then if you go to lower classes, from constants. So let us start with algebraic expressions. What is an algebraic expressions? Variables or numbers joined together by mathematical operators of plus, minus, multiplicative sign and the division sign are called as algebraic expressions. So as you can see, variables, it can be anything from A to Z, which are normally represented by the small letters of the English alphabet. Constants are basically numbers which are having a constant value. So either the variables or the constants or both of them are joined together by the mathematical operators of this. So I have 3 plus x, which is an algebraic expression. I have got 3 into x, which is also an algebraic expression. 3 minus x, or x minus 3, or 3 by x. All these are algebraic expressions, and we can have as many number of terms and as many number of variables as we want also. So 3 plus x plus 5 plus z is an algebraic expression. So any combination of numbers and variables which are joined by these mathematical operators form an algebraic expression. Now in the case of 3 by x, the only condition is that x cannot be equal to 0, because the denominator obviously cannot be 0. Okay, now let us see what is the difference between a polynomial and an algebraic expression, though a polynomial is an algebraic expression. Now let us have a look at a few examples of algebraic expressions. So you can see that I have written a few algebraic expressions over here. Now some of them are represented using a single variable and a combination of constants, whereas in a few cases I have used multivariables or multiple variables. So you can see all these examples I have used only one variable, which is x over here. But in these two examples you can see that I have used x, y and z. Here also x, y and z. Okay. Now, we are going to deal with polynomials in a single variable only. So, because of that particular reason, I will be talking about algebraic expressions in a single variable only for the time being. So, I am going to eliminate this as well as this. Okay. Now, you people must be familiar with the concept of exponent or power of a variable. It is the exponent basically means the power to which a variable is raised. Now that power can be positive, or that power can be negative, that power can be a fraction, or that power can be any number existing in the real number system. So here you can see that the variable is raised to a power of 2. Here you can see that the variable is raised to a power of 2 as well as to a power of 1 over here. Here I can see that the variable is raised to a power of 1 by 3, and here 5 by x is 5x raised to minus 1, right? So it is raised to a power of minus 1. Here it is raised to a power of 1. Here it is raised to a power of 1 by 2. Root of x is x raised to 1 by 2. Here you can see it is raised to a power of 1, 2 as well as 3. Here it is actually x plus x raised to minus 1. So I have got two powers. One is plus 1 and the other is a minus 1. And these two we are not considering at all. So you can see that the powers of x which I have used in this expression range from negative numbers to positive numbers, including fractions. Correct? Also fractions are included. So let me first consider the algebraic expressions that has got powers which are whole numbers. Okay. Here I have segregated the algebraic expressions in such a way that those algebraic expressions in which the variables have powers which are whole numbers, I have written on one side. So here you can see the power of x is 2, here you can see the power of x is 1, here you can see the power of x is 1, 2 and 3. In this side you can see that the power of x is a minus 1 and 1 by 3. Here it is x raised to 1 by 2, so the power is a 1 by 2. Here it is x plus 1 by x, which is plus 1 and minus 1. So in these cases, the powers of x are not whole numbers. Now, this kind of algebraic expressions where the power of the variable is in whole numbers only are called as polynomials. So now you are clear with the distinction between polynomials and algebraic expressions. Algebraic expressions can have any kind of combination between variables as well as numbers which are constants. But in the case of polynomials, you can have any combination, but the powers of the variables have to be whole numbers. Let us see how many of these can be classified as polynomials. Fourth root of x, which is basically x raised to 1 by 4. You know that the power of the variable has to be a whole number. So this is not a polynomial. 1 by x, again the power of the x is a minus 1, so it is not a polynomial. So no. 2 is a constant. Now when there is only a constant and somebody is asking you to identify whether it is a polynomial or not, you need to understand that 2 can be represented as 2 into x raised to 0. X raised to 0 is a 1. So you have a variable standing next to the constant whose power is 0, and 0 comes under the ambit of whole numbers. So whenever you have a constant, let it be any constant for that matter, let it be root 2, root 3, pi or any value for that matter, if somebody is asking you if it is a polynomial, please understand it is definitely a polynomial, no doubt about it. The reason is because you can always put an x raised to 0 next to it. So all constants are polynomials. Okay. So yes, 3 raised to x plus 5. It's a combination of two terms. One is a constant which is 5. The other is 3 raised to x. Now the term 3 raised to x do not fall under the definition of polynomial. A polynomial is a combination of variable and constants in such a way that the power of the variable is a whole number. In this case, the number is raised to a variable. So this is not a polynomial. Okay. Root 3x plus x square. Here you can see that the power of the variable in this case as well as in this case is a whole number. So this is definitely a polynomial. 9y minus y square plus pi. Okay. Now again the powers are whole numbers and pi is a constant. So therefore this is also a polynomial. I hope you can identify when somebody gives you an expression and asks you whether it's a polynomial or not. I hope you people can clearly identify whether this is a polynomial. Fine. Let us consider this particular polynomial 9y minus y square plus y cube plus pi. Okay. And you can see that this is a polynomial in y. So how do you represent a polynomial? If you have a polynomial represented, suppose in the variable x, we write it as p of x, which means polynomial in terms of x. Okay. Now it is not mandatory that we should be using only p of x. If somebody says you q of x or f of x, all these can be represented are representations of polynomial. So 9y minus y square plus y cube plus pi is a polynomial in y. So how do you represent it? I can represent it as p of y. Okay. Now, how many terms are there in this particular polynomial? I have got 4 terms in the polynomial, out of which one term is a constant. Okay. The remaining 3 terms has got variables raised to powers or variables with powers which are whole numbers but not zeros. Okay. The power of variable in this one, it is a 1. Here it is a 2 and you can see that here it is a 3. Right. What is the largest power of the variable over here? You can see that y raised to 3 has the maximum power which is a plus 3. That power is called as the degree of the polynomial. Agreed? Now, suppose I have got another polynomial p of x is equal to x raised to 5 minus 5x raised to 6 plus x raised to 8. What is the degree of the polynomial? You can see that the variables are raised to powers of 5, 6 and 8. So, which is the largest value? 8. So, the degree of the polynomial is a plus 8. Right? So, I hope you are clear with the concept of the degree of a polynomial. Now, I have told you there are 4 terms and you know that in the first term you have a constant and a variable which are multiplied together. In the second term, there is a constant which is actually 1 over here, but we are not writing it because 1 into y square is a y square. Same over here. This constant which is standing along with the variable is called as the coefficient. So, in the first term, the coefficient of y is a 9. In the second term, the coefficient of y square is a minus 1. In the third one, the coefficient of y cube is a plus 1. You have to consider the sign as well. Okay, let us have a look at this particular polynomial. It is a polynomial which is represented by the use of the variable z. So, p of z is equal to this. What is the degree of this polynomial? That is my first question. So, let us see. The first one has a power of 3. The second one has a power of 2 and the third one has a power of 1. I am talking about the power of the variable. So, 3 is the largest value. So, the degree of this particular polynomial is a 3. Clear? How many terms are there? 1, 2, 3. There are 3 terms. Which are the terms? The first term is z cube. The second term is minus 3z square and the third term is a root 5z. Okay. What are the coefficients? The coefficient of z cube is a 1. The coefficient of z square is a minus 3 and the coefficient of z is a root of 5. Clear? So, this is the basic idea of the degree of a polynomial as well as the number of terms and the coefficient. Now, let us see the types of polynomials based on the degree as well as the number of terms. So, as you can see, the degree of a polynomial can vary from right from 0 up to any larger number. So, you can have polynomials of degree 0 or 1 or 2 or 3 and upwards. So, based upon the degree of the polynomial, we have a particular classification of polynomials. The polynomials of degree 0 are called as constant polynomials. So, all the numbers or all the constants come under the definition of constant polynomial. Now, in the case of a constant polynomial, we have one more segregation which is called as a zero polynomial. The zero polynomial is basically the number 0. Okay, so if somebody asks you, is 0 a polynomial? 0 is definitely a polynomial. It is a polynomial called as a zero polynomial which comes under the category of constant polynomial. Now, if someone asks you about the degree of a constant polynomial, suppose you have a constant polynomial 5, okay. I have told you that you have a variable x standing along with it raised to a power of 0. So, what is the degree of a constant polynomial? The degree of a constant polynomial is a 0. Okay. Now, the only exception is zero polynomial whose degree is not defined at all. So, in the case of constant polynomials other than 0, which is a zero polynomial, the degree will be equal to 0. Fine. You have polynomials of degree 1. Some examples of polynomials of degree 1. One is x, y plus 2, y minus 5, root of 5 into x. All these are examples of polynomials where the degree is a 1. Okay, maximum power of the variable is a 1. Such polynomials are called as linear polynomials. Right? We have polynomials of degree 2. For example, you have something like x square minus 3. You can see that the degree of the polynomial is 2. Whenever you have a polynomial with a degree of 2, it is called as a quadratic polynomial. Okay. So, if I have something like this, you can see that the highest power is a 2, it is a quadratic polynomial. Whenever the degree is a 4, it is called as a cubic polynomial. So polynomials of the form x cube minus 3x plus 9, where the maximum power of the variable is a 3, it is called as a cubic polynomial. So when you go up to higher powers, 4, we call it as a biquadratic polynomial, okay, etc. And see, most of the time we will be dealing at your school level only with polynomials whose power, the maximum power you deal with is a 4. You don't go beyond that particular power. So you have got constant polynomial, you have got linear polynomial, you have got quadratic, cubic and biquadratic polynomial. Okay. Constant polynomial, the degree is a 0. The degree of a 0 polynomial, as I told you, it is not defined at all. Now, the general form of a constant polynomial is k or k into x raised to 0. K can be any number, whole number, natural number or integer or any number belonging to the real number system. When k is equal to 0, we end up with a 0 polynomial. Every single polynomial, every single fact that is studied in mathematics always has a general form. Now there are deviations from the general form, but unless in physics and chemistry, you don't have to bother too much about it because this is only theoretical. So the general form of a constant polynomial is this. Let us see what is the general form of a linear polynomial. Okay, now you know that the degree of a linear polynomial is a 1. Okay, I have given you examples x plus 2, x minus 3, root 5 into x, etc. Now, you know that whenever you are representing a polynomial, whether it be of any power, the remaining terms ideally should have powers in a reducing number, which means that suppose you have a polynomial whose degree is a 5. Ideally speaking, the first term has a degree of 5, second term has a degree of 4, third term has a degree of 3, and the last term should be a constant. This is the ideal form. 5, 4, 3, 2, 1. Suppose the degree of a polynomial starts is a 3, it's a cubic polynomial. The second term should have a degree of 2, the third term should have a degree of 1, and the last term should have a degree of 0. Now, you know that it doesn't always happen. Sometimes you miss this term. The term having degree power 2 is not there. Constant term may not be there in the polynomial. It's absolutely fine. But the general form should be in this way, which basically means the degree of a linear polynomial is a 1. Ideally speaking, it should have two terms, one having a degree of 1, other having a degree of 0. So let me define or let me write down the general form. The general form is ax plus b, where a can be any number other than 0, b can be 0. Ideally speaking, b should not be 0 because we want the term b to be there. So for example, if you have x plus 3, compare x plus 3 with this general form. What can you say? The value of a is a 1. The value of b is a 3. Let us take another example. Root 2x. Compare this with ax plus b. The value of a is a root 2 and the value of b here is a 0. We don't have the b term. All these are examples of linear polynomials, but this is a general form where the first term has a degree of 1 and the second term is a constant having a degree of 0. Ax plus b is a general form of a linear polynomial. Now what will happen when the value of a becomes a 0? When value of a becomes a 0, this entire term will disappear and we have only b over there. Now the linear polynomial has become a constant polynomial. So it is very mandatory that the term x, the term containing x has to be there for the polynomial to be a linear polynomial. Okay, so now let us look at two more examples and identify the value of a as well as b. Suppose you have a polynomial which is represented by x by 3 minus 9. What is the value of a and b? This is a linear polynomial because the power of x is a 1. Comparing it with ax plus b, the value of a is a 1 by 3 and the value of b is a minus 9. Okay. Suppose you have a polynomial 3x plus pi. The value of a is a 3 and the value of b is a pi. Clear? So the general form of a linear polynomial is ax plus b. Right? Now let us move on to the quadratic polynomial. So in the case of a quadratic polynomial, you know that the highest power should be a 2, and ideally speaking, it should have a term having a power of 1 and a 0. Now let us write the general form. It should be ax square plus bx plus c. C is the term having 0 degree, bx is the term having degree 1, and this is the term having degree 2. This is the general form. Let us write down a few examples so that you get a better idea of how to identify a, b and c for a quadratic polynomial. So suppose you have a quadratic polynomial of the form this. X square. So what is the value of a? A is 1, b is 3 and c is 4. Okay. Now in the general form of a quadratic polynomial, you know that a cannot be 0 at all, because if a is 0, there will be no quadratic polynomial. The x square term will vanish. You will get only a linear polynomial. So a cannot be 0, but b and c can be 0. Ideally speaking, let it be there, but non-ideally, it can be 0. So if you have a term 3x square, what kind of a polynomial is this? This is a quadratic polynomial where the value of a is a 3 and b as well as c both are equal to 0. Clear? Now, 4x square minus 5. This is a quadratic polynomial where the value of a is a 4, the value of b, which is a coefficient of x, is a 0, and the value of c is a minus 5. I hope you are clear with the general form of constant, linear and quadratic polynomial and which terms can be 0 and which terms cannot be 0. Let us talk about cubic polynomial. Cubic polynomial is a polynomial whose maximum degree is a 3. Ideally speaking, I should have term having degree 2, 1 as well as 0, right? So how do you write it? Ax cube plus bx square plus cx plus d, where a cannot be 0, b, c and d may or may not be 0. Okay, let us take some examples. 3x cube plus 5. Compare with the general form. The value of a is a 3, bx square term, x square term is not there, b is a 0, c is a 0, but the value of d is a 5. Okay, 5x cube minus 6x plus 9. The value of a is a 5, the value of bx square term, x square term is not there, b is a 0, c is equal to minus 6 and this is d. Okay, so now I have told you the general form of the 4 basic types of polynomials. This is the classification of polynomials based on the degree. Now let us see how polynomials can be classified based on the number of terms. Now you know that a polynomial can have a single term, 2 terms, 3 terms, or from 3 you can have any number of terms. So a polynomial having only one term like a 5x or a 6 or a 7x cube, such kind of polynomials are called as monomials. Polynomials having one term. Okay. When you have a polynomial of the form x minus 5, 3x square plus 9x, these are all polynomials having 2 terms. One term is x, the other term is minus 5. Such kind of polynomials are called as binomials. When a polynomial has 3 terms, look at this polynomial, it has got 3 terms. I can call it as a trinomial. Okay, beyond trinomial, we just say they are polynomials having 4 terms, polynomials having 5 terms, etc. Now I will give you a few examples. I want you to identify whether those polynomials come under monomial, binomial, trinomial and also constant, linear, quadratic or cubic. Okay, a polynomial can be a cubic as well as a monomial, correct? Let us take a few examples and make this particular concept clear. 3x cube, it is having only one term, so I can call it as a monomial. But what is the degree? The degree of the polynomial is a 3. It's a cubic polynomial. So I can say that it is a cubic monomial. Okay. Now, in this case, first we identify the degree. Okay. What is the degree of this particular polynomial? You can see that it's a polynomial of degree 2, which is a quadratic. How many terms are there? 1, 2, 3. It is a quadratic trinomial. This degree is 3, number of terms is 2, cubic binomial. 4. How many terms are there? Only one term. It is a constant polynomial. It is a constant monomial. Even when you say constant, it will have only one term. So even if you write it's a constant polynomial also, it is right. But then to be more specific, constant monomial. 0. 0 is a zero polynomial. In this case, we do not have to mention it is a monomial because 0 is a special case of constant polynomial whose degree is a 0, whose degree is not defined. So you just write it as a 0 polynomial. Okay. Here, highest power is a 3. It is a cubic. How many terms are there? 4 terms. So you say it's a cubic polynomial with 4 terms. This is a biquadratic binomial. 2 terms. This is linear binomial. Degree is a 1 and the number of terms is a 2. This is how you classify a given polynomial based on the degree as well as the number of terms.